Alright, so I'm going to go over some notes that we took in class today. I'll go ahead and do this again for those of you who missed it or need a recap. At the top, I've recolored this periodic table just like we've done in class, where we've got red are the nonmetals, green are the metals, and the yellows are the stair step that goes between the metals and nonmetals. That's called the metalloids or semiconductors. So that should be a recap. If you need to do that, then you can. You may want to use that to help you out, maybe not. You can just use your original if you'd like. So first, I'm going to put some information down, and I want you to pause it and see if you can fill it out ahead of me. So on this, we're going to draw an atom. I'm going to draw the number. I'm going to give you the number of protons, neutrons, and electrons. The number of protons is going to be 3. It's going to be 3 neutrons. There's going to be 6 electrons. So I want you to write, what is the charge of this atom if it has 3 protons, 3 neutrons, and 6 electrons? What is the charge? Positive, negative, and how much? I want you to draw the protons, neutrons, and electrons inside of this atom where they belong. And I'll show you a way of doing that down here. But so if you think you know how to do it, go ahead and pause it and you can do it. We're just going to go ahead and do it as if you don't know. So this will be educational if you don't know. I'll go ahead and draw the protons on the inside. I'm going to draw those with a plus. The neutrons, I'm going to draw those with just a dot or a circle if you want to do that. There's going to be 3 of them. And then the electrons, I'm going to draw with an orange color. So there's 6 of them. The first ring gets 2, and that ring is full. And then 3, 4, 5, 6. And I like drawing them even like that. If you would prefer, you can draw them out. You can draw them right here if you want. Just if that's easier for you to count, that's fine too. But 1, 2, 3, 4, 5, 6. There's 6 electrons. So that's the Bohr model of the atom. Then we're going to do this down here. You may already be able to tell what the charge of this is. If not, this is what you need to do. I'm going to redraw those protons down here, and redraw the electrons. There's 1, 2, 3, 4, 5, 6. And these two cancel out, plus and negative. These two cancel out, plus and negative, and plus and negative, they cancel out. And we're left with 3 negatives. There's 3 remaining electrons. So this atom has a -3 charge. All right, I want you to do the same thing for this next one. I'll go ahead and draw protons are going to equal 2, neutrons are going to equal 2, and electrons are going to equal 2. And then this one over here, do the same thing. Protons are going to equal 3, neutrons are going to equal 3, and electrons are going to equal 1. So you need to write what the charge is, what the charge is, draw the picture, and if you need to, draw the pluses and minuses to prove that what you're saying is true. You do the same thing for this. These are the completed notes for the front. You can go ahead and pause it there, see what you got. You can compare what I've got to what you've got, and then we'll flip over to the next page. So for this, I want you to go ahead and add oxidation numbers up here at the top. And if you remember, oxidation numbers tell us what charge these ions have. So the alkali metal group is going to be a +1. Alkali earth metal is going to be a +2, +3, plus or -4, -3, -2, -1, and 0, because this one is full. This valence electron is full. So this group right here, the fastest way for it to become a noble gas, which is what all of them are wanting to do, and that's a little bit of personification or anthropomorphism, where these atoms don't really want to become, but we're kind of assigning human traits on it. This column we're going to say is wanting to become like the noble gases. So the fastest way that it can do that, for lithium, it can either gain 1, 2, 3, 4, 5, 6, 7. If it gains 7 electrons, it'll have a full valence shell. Or if it just loses 1, it'll have a full valence shell like helium. And so we're going to go the closest way to the noble gases. So for group 1, it's going to be to lose 1 electron, which means it's going to be positive. If it loses 2 electrons, it's going to be positive 2. If it loses 3, 1, 2, and 3, that's going to be plus 3. The same thing we would start over here. The easiest thing for this to do, for the halogens to do, is for it to gain 1 electron. And because it gains 1 electron, electrons are negative, and if it gets an extra electron, it's going to be negative 1, and then negative 2, negative 3. And carbon can go either way. It can gain 4 electrons, 1, 2, 3, 4, and that'll be a negative 4. Or it can lose 4 electrons, 1, 2, 3, 4. It'll be a positive 4. So those are oxidation numbers. If you don't know those, you need to, I will write those on the top of your periodic table and make sure you understand why, because given a blank periodic table, you should be able to fill those in as well. I want to write down octet rule, which is what we just talked about. Elements want to have 8 electrons. For the case of helium and hydrogen, just 2. But for most of them, it's going to be 8 electrons in the valence shell, or ring, or that outer circle. For charges to be balanced, there should be a F. For charges to be balanced, the oxidation numbers must add to 0. So we're going to do a little bit of practice down here at the bottom. For sodium, if you look up at sodium, sodium would be an oxidation number of 1. It's going to be a plus 1. Magnesium, if you look up there at the top, right here, it's going to be a plus 2. So I'm going to go ahead and stop there. I'll let you fill out the rest of these, and then I want you to tell if these two atoms came together and they made an ionic bond, what would they be balanced or not? And I'll go ahead and finish this first row so you understand. So sodium is a plus 1, chlorine, as you can see, is a negative 1. So they would be balanced if they came together. If sodium and chlorine came together, they would be balanced. So I want you to finish the rest of this chart, and you can look back in just a second. Alright, so here are the answers to that. So that should help you. If you understand how to do that, you're good for this page. We'll flip it over to ionic compounds. Alright, so I've had to fold this so I can get into the camera view. An ionic bond is formed as a result of a loss or gain of electrons. So ionic bonds are formed as a result of a loss or a gain of electrons. Now this next section is elemental composition. This just means what is the element, what are these elements composed of or made of? Or what elements compose them is what I mean, I'm sorry. What elements compose them? So for ionic compounds, there are metals and nonmetals. They are made of metals and nonmetals. And so if you look at your periodic table, you're going to have the metals that are going to be over here, and the nonmetals are going to be up here, including hydrogen. All right, ion. This is very similar to our ionic bond definition. An ion is a charged particle because of the loss or gain of an electron. I want to talk about the two different types of ions. We've got cations, which again it looks and it's spelled just like it sounds. We've got cations and anions. Cations, the way that I remember this, let me back up. These are the two parts of the ionic bonds. We've got metals and nonmetals. One of these is going to be positive and one of these is going to be negative. And so one of these is going to be positive, one of them is going to be negative. Best way that I've remembered this is by saying that cats have paws. So the animal cat has paws. Cats are positive. Cations are positive, and I'll write that at the end. And another teacher, I heard them say that anions are like onions. Onions are they make you cry, which is bad. Or you can think about literature. An antagonist is a person that is the bad guy that's in the story. An antagonist that's against the protagonist. So either one of those are okay. I'm going to write these definitions and make sure you understand the difference between a cation and an anion. All right, so cations are the positive charge. They have a positive charge due to losing an electron. Cats have paws, or cations are positive. And anions are a negative charge due to gaining an electron, which is like an antagonist. And if you'll notice, it's losing an electron or gaining an electron. And one's positive and one's negative. Those are the differences in those definitions. Those definitions are exactly the same except for those two words. All right, we're going to talk about boiling point. You can just do like a greater than sign. I'm going to do one of these fancy ones. So it's summarizing. The boiling point and melting point for ionic compounds is very high. And that's because metals and nonmetals, when they connect to each other with positive and negative, when they connect to each other, it is very, very strong. It's a strong connection. So the boiling point is high due to needing a lot of energy to break it. So the boiling point and the melting point are that. So they're high due to needing a lot of energy to break it. Remember, when we talked about states of matter, everything is moving, and as their two particles are slowly moving, as you increase heat, they're moving faster and faster and faster and faster and faster, and eventually they'll break apart. The tie that holds them together will break apart. And with ionic compounds, they hold together for a very long time. The other compound, the other kind of bond that we're going to talk about are covalent bonds, and they break apart a lot easier. And we saw this in salt and sugar. You can melt sugar pretty easily. You cannot melt salt very easily. It's very difficult, very, very high temperatures to melt salt. So, and then conductivity. For conductivity, they are very conductive. Oop. Very conductive. Because it has metal in it. It's very conductive because it has metal in it. Again, we're dealing with metals and nonmetals. Covalent bonds are going to be nonmetals and nonmetals. But because this has metals in it, you should be easy to remember that it's very conductive. It can take electricity, and it transfers electricity and heat very well. All right, on this, I wrote a little note up here at the top. I wrote calcium with a +2 and calcium with a 2 below it. And you need to rewrite this and understand that this +2 is saying the oxidation number is 2. It has a +2 charge, which we can see if you look back at the periodic table. This, with a little 2 below, it's a subscript. This is a superscript. It flies up in the air like Superman. It's up high. Subscript, like a submarine goes below the ocean, or a subway is below a city. Subscript is just telling you that there's 2 calcium atoms there. And so write that down if you don't have it. Let's talk about these rules. for writing ionic compounds, a cation, which is the middle, is always first, and the anion, which is the non-metal, is always second. And if you think about how the periodic table is set up, you've got metals over here, non-metals over here. So if you just read it from left to right, it should be pretty easy to remember that. Also remember that the cation always has the same name as the element. The first one, the metal, so if it says Mg, it's magnesium, which seems kind of a duh thing, but if you get to this point number 3, rule number 3, anion is the normal element name, but it ends with an IDE. So you drop off the last little couple letters and you add an IDE. So oxygen becomes oxide. Oxygen becomes oxide. So let's go ahead and write these. I'm going to give you 2 things to practice. Oop, not a G. Calcium, we'll start with calcium. And nitrogen. Boron. And fluorine. So we need to, we're going to start with these 2. That's what you're given. Those are the 2 ions. We're going to do the crisscross method. Before we do that, I want you to follow some steps. And this is, I know this is not very, it's a little sloppy, but this is what we're going to do. Write the element symbols, and then write the oxidation numbers. And so for calcium, look on your periodic table. Calcium's oxidation number is a +2. Nitrogen's oxidation number is a -3. It's in that column with -3. And then for this step, this is an extra step just to teach you how to do it. We're going to rewrite that. +2, nitrogen with a -3 charge, and then we're going to crisscross. And you can do this with your pencil. I'm going to draw it with the different color so you can see it better. We're going to crisscross. We're going to take this 2. I want to put it right here. We'll take this 3, and I know it says -3 because it's a -3 charge, but we lose the signs when we come down. It's just going to be a positive number. It's going to be a 3. So now what we're left with is Ca3 Na2. See, the 2 came over to here, from here down, and the ends -3 charge comes over here. And there's a more complicated way of doing this. There's a reason why we take this little shortcut. Just so you know, this is a lot easier. So if you can follow this crisscross method, what this is saying is if calcium is a +2 charge and nitrogen is a -3 charge, it'll take 3 calciums and 2 nitrogens to make a neutral atom, which is where, remember, it's sharing that in this atom there's the same number of protons and electrons. I'm sorry, in this compound there's the same number of protons and electrons. These charges equal out. Here's what I mean. So if we have calcium, remember, which has a +2, calcium +2, calcium +2, and nitrogen -3 and nitrogen -3. We've got 2, 4, 6 on the left side, +2. And for nitrogen, we've got -3, -3. That's -6. We've got a +6 and a -6. That cancels them out. That is a happy element because it has the same number of, it's got a neutral charge. Same number of protons and electrons in the whole compound. So then we name the compound. The name of this compound is calcium nitride. Calcium, just like normal. That's rule 2. Write it like it is. And then for this one, nitrogen, instead of writing nitrogen, we're going to write nitride. Remember, it ends with an IDE. Okay, I want you to go ahead, I'm going to pause this, and I want you to pause it, and I want you to go ahead and fill out this one just like we did for the one above. Go ahead and pause it now. Alright, so I filled it out, I changed the colors, and you may notice in yours you may have put a B1 here. If you did it right, you probably put a B1 right there, and that is perfectly fine. That's not really how we write it. If you write that, it doesn't mean it's wrong, it just means it's a little bit goofy, and that's fine. And so we just say BF3, and then the name of it would be boron fluoride. boron fluoride. And then let's jump down to here. Oh, right here, I didn't go over this, reduce. When we do this crisscross method, the first one we didn't need to do that, and the second one we didn't either, but we may need to do that in the future. If there is a way of simplifying what we've got, for example, if it was, I'm just going to make up something, x3 and y3, just simplify that as x, y. You just turn those to 1. So because if it's the ratio is there's 3 x's and there's 3 y's, is the same as 1,000 x's and 1,000 y's, or 1 x and 1 y. The ratio is the same. Or if you were to have, if you were to do, there's 2 x's and 4 y's, you could simplify that to x1, y2, or just xy2. And if that confused you, that's fine. Let's go ahead and practice what we've got first, and we'll get to that. So the simplify or the reducing part is can be a little confusing because maybe the math is not your strong suit, but we'll get there. I think you'll be fine. All right, magnesium nitride. So we know magnesium is Mg. That one's going to be just like it's written, magnesium. And nitride, if you were to put a different ending here, it'd be nitrogen. So it's going to be N. And then we need to look for what those charges are. Magnesium is typically a +2, or not typically, but it is a +2. And nitrogen is a -3, so we're going to crisscross those. We've got Mg3, N2. All right, go ahead and I'll go ahead and write. I want you to go ahead and pause it here, and you can fill out the rest, the other 4 boxes. All right, and that's how you write ionic compounds. If you want to, you can check your answers at the bottom down there. If you have any questions, you can let me know in class. Or there's other videos in your resources that you can go watch other videos. You can watch somebody else explain it differently. But this is the concept.